सन 1903 हवाई जहाज के इन्वेंशन ने बदल दिया दुनिया के आने जाने का तरीका। 2022 वेदांतु लॉन्चेस AI लाइव और यह बदलने वाला है दुनिया के सीखने का तरीका। इंटरैक्टिव क्लासेस, टॉप टीचर्स, सिर्फ 5,000 रुपए सालाना।
What's up, people? How are you guys doing? I hope all of you guys are doing very well. I know it's a Sunday. It's supposed to be the day where you're supposed to have fun, but then we have to study because no matter what you say, you have to put in your efforts. I know your exams are long way ahead, but still you need to put in the effort. And with that said, people, we are going to learn something very important today, something very interesting, something that I'm going to keep it very short and sweet so that you understand the whole concept in the next 10 to 15 minutes. So without wasting much of your time, my name is Anup. This is Vedantu's 9th and 9th English channel. Before we start, hit that like button, subscribe to the channel so that God can shower you with a lot of good luck and prosperity. Peace. Alright, so that's it, guys. Let's talk about today's topic. But before that, I also had a simple homework question that was asked in the previous session. This was a question basically. What is the nature of incident rays when the object is at infinity when kept when the rays of light, or when you can say that when the mirror is basically a concave mirror. If you have a concave mirror and you have an object kept at infinity, what is the nature of the incident ray? The answer to that question, people, is nothing but parallel. So when the object is kept very far away, the rays of light are passing through the same exact medium. So we are assuming that all those rays of light are parallel to each other, which means that after reflection, they will all meet at the exact same point, which we know as the focus. Now, before I go any further ahead, for all those who are wondering what is focus, what is incident ray, what am I talking about, please go to the previous sessions because we have done all of this in a very fun and interactive manner. Make sure you check that out because once you understand that, whatever I'm going to teach you today will be like cakewalk, will be like super duper easy. It'll be like Salt Bae putting salt on his half-cooked meat. Getting it? Alright, so let's get into the topic of convex lenses. Now convex mirror. Before we talk about convex mirrors, people, before we talk about the ray diagrams of convex mirror, we need to revisit the topic of sign convention. Now we've already studied the sign convention in the previous session, but just a quick reminder because we all have the tendency to remember everything. I'm pretty sure if I ask you what you had for breakfast, 90% of you guys will be looking up in the sky and thinking, what did I really have? So I know, because I'm in that category. So for that reason, people, will just quickly go through what all we have studied in the previous session, and that is basically the sign convention. So what is the sign convention? So in order to understand the sign convention, I took a very simple example of the Cartesian planes. If you remember, Cartesian planes is something that you have studied in your lower grades in geometry, where you took this as the x-axis, this as the y-axis, and this as this is x dash, y and y dash. Unfortunately, my pen is not working, so I'll not be able to write anything much today. So I'm just going to show you with my pointer. So please pay attention to the pointer here and there. All right. So this is going to be x, this is going to be x dash, this is y, and this is y dash. And you already know that x is considered to be positive, x dash is negative, y is positive, whereas y dash is negative. Now the exact same thing we're going to use over here also, just like what we did for a concave mirror. The same sign convention is applicable for a convex mirror as well. So let's say you have a convex mirror. Now what we're going to do is we're going to keep that convex mirror exactly at the origin. So when you have a Cartesian plane where you have x and y axis meeting, that point where they're both intersecting, that is nothing but the origin. So we are assuming that the convex mirror, I'm again and again saying lens, the convex mirror is kept exactly at the origin, which means that all distance that you measure towards the front or towards the left hand side, towards your left hand side, towards the left hand side of the mirror, that will be considered as negative, and all distances behind the mirror, that is basically towards your right hand side, would be considered as positive. And this holds true for convex mirrors, also concave mirrors as well, because we've already studied that in the previous session. And we also know that all distance above the principal axis is positive and all distance below the principal axis is negative. The exact same thing we're going to replicate over here also, no change whatsoever. And we're going to try to find out what type of image is going to be formed if I were to keep the object at different positions. So let's say there is a person, I think that is Mr. Abhishek with a weird dress. All right. Okay, I wasn't expecting that. I think he's holding a book also. Oh, nice. So Mr. AKR sir with his beautiful smile, standing like a stick figure right there, holding something in his hand, is the object. What a beautiful way to imagine, right? You can imagine the miniature size of AKR, the bobblehead wala thing. So every time you hit the head, it goes gulu 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 gulu. So it's that kind of thing. All right. So let's say that that is the object, and you're keeping that object in front of a convex mirror. So the distance from the mirror, that is towards the left hand side, is considered as negative, which means Abhishek sir at this point of time, if you talk about the distance, which is nothing but the object distance, that would be negative, and the distance behind the mirror is considered to be positive. Now one of the most basic things that we learned in the very first session is something called as the focus and the center of curvature. Now for a convex mirror, the center of curvature and focus, both of them lie behind the mirror, which means that both the focal length and the radius of curvature here is going to be positive, whereas Abhishek sir, like his nature, is going to be negative. As simple as that. Now, some of the examples of convex mirrors are basically all around you, from parking mirrors that you have to side view mirrors of cars. All of these use convex mirrors itself. Now here, all in all, you can see there are different application of this convex mirror. You can use it to see what's right around the corner. You can use it in parking lots. You use it in shops to see if someone like Abhishek sir is stealing and putting things in his pocket. So all of these can be found out using a convex mirror. Now let's talk about the ray diagrams. But before we talk about ray diagrams, before we start with the whole concept of ray diagrams and I start telling you, spitting out the facts, let me ask you one question. Why do you need ray diagrams? What do you need? What could be the possible reason for it? Think for a second. Chalo, socho. See guys, when you talk about objects, when you talk about mirrors, now you know that if you keep the object at different positions, you will get different images. But a ray diagram helps you to figure out the approximate, not the exact, but the approximate position of that image, which helps you in basically building or creating or inventing devices. For example, let's say I want to make a parking lot mirror. Now I need to know how much area should be covered in that on that particular mirror. In order to understand that, I need to draw a rough ray diagram. I need to know the ray diagrams, and that is why we need ray diagrams. It basically gives you not the exact position, but the approximate position, the type, the properties, all of that can be figured out using nothing but a ray diagram. And you know what, people? Unlike your concave mirror, which had basically 6 different ray diagrams, humongous, I know, but unlike a concave mirror, a convex mirror on the other hand has only 2. That's it. Simple as that. Just 2 ray diagrams and you're done. The first ray diagram is this. If let's say you have an object which is kept at infinity, let's say you're talking about the sun. The sun is about 150 million kilometers away, right? It's about 150 million kilometers away, which is very far. So we can assume that sun is at infinity. And let's say I have a convex mirror that is placed, right under the, it's kept under the sunlight. In that case, we are going to assume that the rays of light coming from the sun are parallel to each other, which means that since concave mirror is a converging mirror, you would have seen that all these rays of light would have met at a point called as a focus, which is in front of the mirror. But in a convex mirror, since it's a diverging mirror, these rays of light will go away from each other like you see right here, and it happens such a way that they appear to be meeting at the origin. Now here's the difference. In a concave mirror, they are actually meeting at the focus. They're actually meeting at the focus. But in a convex mirror, they only appear. They're just pretending. Getting it? They only pretend to meet at the focus. That is the difference. So here what you have is a virtual image because the rays of light are not really meeting. Now, if you also look at one more thing, the image is so minuscule, so tiny that compared to the object, you can say that it's a highly diminished image, or you can just say it's a diminished image. And we also know that virtual images are always erect in nature, which means that this will also be erect. As simple as that. That is your first ray diagram. The second ray diagram is even more simpler than that, because all you have to do is this: keep the object wherever you want. Wherever you want. That's it. No matter where you keep the object, it really doesn't matter. I'm going to take two standard incident rays which you have learned in the previous session. One which is parallel to the principal axis and the other passing through the center of curvature. Now you see a ray of light parallel to principal axis after reflection appears to pass through the focus, just like in this one. Another ray of light which is passing through the center of curvature again gets reflected back in the same path. Now here the center of curvature lies behind the mirror, so the ray cannot actually pass the center of curvature, but it appears to do so. Now you can see that these two rays of light are meeting at a point between the pole and focus. And guess what, people? That is where the image is formed. And the best part is, it doesn't matter where you keep the object. Let's say you bring it closer, still the image is going to be formed between P and F. Let's say you take it far away, still the image is going to be formed between P and F. As long as the object is not at infinity, anywhere from infinity to pole, the image will be formed between pole and focus. But there's a small catch. As you bring the object closer and closer to the mirror, the image will also come closer and closer to the mirror. That is the only condition. As you bring the object closer and closer, the image will also get closer and closer to the mirror. As simple as that. And this, my friends, is your convex mirror ray diagrams. As simple as that. As promised, in 10 minutes, done. But we're not done yet, people, because I also have some quizzes. Obviously, you're here to learn. So let's test your knowledge. So let's do a couple of quiz questions. Now, here's what I want you guys to do. Put it on in the chat box. Put it on in the comment section. Let me know how many of you guys got all of the answers right. And I want to see the numbers. All right, people. I want to see the real numbers. Don't fake it. All right. I know there's a saying, fake it till you make it. But don't be Abhishek sir. All right. Be you. So here's the first question on your screens right now. If the source of light is kept at the focus, which of the following will form a parallel beam? If the source of light is kept at the focus, which of the following mirror will form a parallel beam? Options are a concave mirror, a convex mirror, a plane mirror, or a biconvex mirror. Now, what is a biconvex mirror? We'll talk about that later. But here is the question for you people. I'll give you guys 5 seconds to think. Now, if you need more time, it's YouTube here. Pause the video, think about the answer, put it down. What is the big deal? Let me tell you the answer in 3, 2, 1. The answer is gonna be concave mirror. Why is that so? Because the focus of a convex mirror lies behind the mirror. If you keep an object behind the mirror, will it do anything? There'll be no reflection, nah? So will it become parallel? No, absolutely not, because it's behind the mirror. So the only right answer in this case is going to be a concave mirror. Whoever got it right, fabulous job, people. Super awesome. You guys are very, very smart. Second one. A boy stands in front of a mirror at different distances. Still, his image appears erect. Now, this mirror must be what? This must be a plane mirror, 100%, sir. This must be a convex mirror, 200%, sir. This must be a concave mirror, 350%, sir. Or option D, plane and convex, or plane or convex, 500%, sir. Which do you think is the right answer? Go ahead, people, think about it. Let me know what is the answer. Is it plane, convex, concave, and or plane or convex? The image is always erect, no matter where you're standing. What do you think? Use that brain, people. Use that brain of yours. Use that amazing Sherlocky brains. The ones that you use to find who killed who in a movie. Like what sort of next KGF movie is going to come out, or what sort of next Marvel movie is going to come out. Use that brain for this one as well. I'll start the quiz in 3, 2, 1. The answer to this question is option number 30. Because it can be either plane or it can be convex. Let me tell you why. Because a plane mirror always forms an erect image. We know that. Done and dusted. We just learned that even a convex mirror always forms an erect image, because in a convex mirror also the image is always virtual and diminished. And hence option number D. Simple. Khel khatam, dukaan band. Alright, let's go on to the next one, guys. Here's another one. An object is placed in front of a convex mirror at a point between infinity and the pole of the mirror. So the object is placed between infinity and the pole. The image formed is real and enlarged, virtual and enlarged, real and diminished, or virtual and diminished. I'm pretty sure you have already put on the answer in the chat box. Hats off, kudos to you people. Let me tell you the answer in 3, 2, 1. Because you know this, I'm not going to give you much time, because you already know the answer for this. It has to be option number D. No doubt again. Because a convex mirror always forms virtual, diminished, and an erect image. As simple as that. With that said, guys, let's go on to the last and the final question for today, because this is the deciding one. No matter how many wrong questions you've given, wrong answers you've given so far, this is the one that is going to make it out, right? It's like the golden goal in football. Here it is. The image formed by a convex mirror is always virtual erect smaller, virtual erect and bigger, real erect and smaller, or real inverted and bigger. Like I told you, the golden question, the golden ball, or super over wala question. Let's go, people. The image formed by a convex mirror is always what? In 3, 2, 1. Option number Anup. A for Anup. It has to be virtual erect and smaller, or diminished. It's always virtual erect and smaller. As simple as that. But again, people, we are not done yet. We're not done yet, because I also have a homework question for you people. This is your homework question. Let me know in the comment section, and those students who puts it down the fastest would be having their name spread to the world through the channel in the next one. The question is, the image of an object which puts in front of a convex mirror is formed dash. An image of an object which is put in front of a convex mirror is formed dash. All right, the image of an object which is put in front of a convex mirror is formed at dash. Very simple question. You know the answer. Where is the image formed? As a question in simple words. Put it in the comment section. Let me see how many of you can get this right. And with that, people, we will end today's session. Thanks a lot for joining. But if you guys enjoyed the session, and if you want to know more about this, about the whole platform of Vedantu, and you want to join the courses and start your preparations right away in a fun and interesting manner, you can see a number, a WhatsApp number that is scrolling down at the bottom. Click on that number, save that number, send a hi to that number, say that your name is so and so, and you're texting them after watching my session, Anup sir's session. And you can also mention which family you would like to join. Would you want to join the 9th standard, 10th standard family, NEET, JEE, whatever it is, put down over there. you'd be getting a call back with the experts to explain how you can be a part of this amazing family and how you can kickstart your preparations. So until the next time we meet, until the next time we see each other, stay safe, stay hungry for more knowledge. I'll see you soon. Take care. Peace.